Have you ever wondered how NASA's Ingenuity drone managed to fly on Mars? How did it navigate through the Martian terrain and overcome the challenges of the planet's thin atmosphere? Hey there, folks. Welcome to our channel. Here we explore the latest trends and developments in the tech industry, from cutting-edge technology to the latest science discoveries. In this video, we will explore the possibilities of NASA's Ingenuity drone. But before we move forward, don't forget to like the video and subscribe to our channel and tap the notification bell so you won't miss any of our uploads. Let's discuss the concept of sending self-governing airborne vehicles to extraterrestrial planets. NASA's Ingenuity Helicopter, stationed on Mars, has performed remarkably well during its initial tests and has surpassed the scientists' initial expectations. Initially, the experts had doubts about the drone's ability to function in the thin atmosphere of Mars. However, within a few months of trial, Ingenuity has proved to be an incredibly valuable asset for Mars exploration. The rapid progress in artificial intelligence and automation has opened up a universe of possibilities for what these self-sufficient flying machines could discover in our solar system. In the forthcoming decades, Ingenuity shows automation. On January 27th, the Ingenuity Mars helicopter achieved a significant milestone by testing out its new software updates. The helicopter flew up to the top of a rocky delta cliff to scout a path for Perseverance to follow. The two robots have been on a mission to survey an ancient muddy river delta at the edge of the Jezero crater on Mars for the past several months, a project known as the Delta Front campaign. As the mission is nearing its end, Perseverance's next leg is planned to take it up the river, which involves a climb up a steep cliff formed at the head of the old delta. Typically, Perseverance uses Ingenuity to scout ahead for easier routes through potentially dangerous terrain. However, it's not easy for the small helicopter as it was designed to take off and land on relatively flat terrain. While it has a suite of cameras and sensors to help it pick out safe landing sites, the Jezero crater and the delta leading out of it are extremely rough areas, making it difficult for technicians to plan safe flight paths for Ingenuity. The success of the Delta Front campaign relied heavily on the cooperation between the Perseverance rover and the Ingenuity helicopter, and when the campaign concluded, NASA knew that Ingenuity would need some help to scout the delta top. The delta top refers to the area at the top of the steep ridge that Perseverance has been studying, and up until recently, Ingenuity likely wouldn't have been able to complete this sort of flight. The new software updates for Ingenuity are a significant development for the mission as they allow the helicopter to operate in challenging terrain, which was previously impossible. Without the updates, Ingenuity would have either aborted the flight or crashed into the cliff face, which highlights the importance of the software updates. NASA's solution to the problem was to program Ingenuity to use digital elevation maps instead of assuming a smooth flight path. The drone's sensors now double-check its position against terrain data, ensuring a safe flight path. After a few test flights to configure the software in late November 2022, Ingenuity completed its 41st flight to the delta top area without any problems. However, it is crucial to remember that Ingenuity's original mission was only for 5 flights. It was designed as a tech demo to show that we could build something that flies in the thin Martian atmosphere. The atmosphere on Mars is 1% as dense as ours, making flying at a near ground level equivalent to flying at an altitude of about 1,000 feet on Earth. Ingenuity had to be designed to fly without human input, which is why it is a valuable case study for robotic exploration. Ingenuity's programming also enables it to cycle power into the battery, startup heaters to prevent freezing overnight. Without this automation strategy, operating missions on Mars or further into space would not be possible. NASA's Dragonfly drone is an exciting development in our ability to explore distant worlds, building on the lessons learned from Ingenuity. The quad-propeller drone is being designed to fly on Saturn's moon, Titan, and although its launch has been delayed until 2027, Dragonfly represents a significant step forward in our ability to explore outer solar system bodies. Titan is a moon with an incredibly dense atmosphere, about 4 times that of Earth's, which presents a different set of challenges than those faced by NASA with Mars exploration. The air on Titan is so dense that flying will be relatively easy in comparison. This is why NASA plans to fly around Titan instead of driving on its surface, as the majority of liquids on Titan are made of methane and ethane, making ground travel difficult and potentially dangerous. Dragonfly is a 1,200-pound vehicle that NASA predicts will be able to fly much longer and further than Ingenuity. To give some perspective, 1,200 pounds is the weight range of the heaviest Martian rovers, like Perseverance. However, if controlling Ingenuity at Mars range is challenging, it will be nearly impossible to control Dragonfly at Titan range. A signal from Earth would take about an hour and a half to reach Saturn's moon, which means Dragonfly will likely need a relay satellite to communicate effectively. This presents challenges for quick maneuvers on the surface of a world about which we have very little information. Dragonfly is expected to use similar terrain detecting software to that which Ingenuity is currently testing. The mission will also leverage the data collected by the Cassini probe and its Huygens lander in 2005. However, the Rashid lunar rover may provide an additional advantage to Dragonfly. Rashid is equipped with an AI that uses machine learning algorithms to search for, identify, and catalog minerals and interesting formations. This technology would be a huge help in finding potential survey sites and would take a lot of pressure off the ground teams back on Earth. Technicians would teach the algorithm to look for the same signs that scientists look for when analyzing sample data, and the robot would experiment until the technicians confirmed its success. While there hasn't been confirmation that Dragonfly will have this sort of capability, it is still in the design phase, and the technology could be incorporated before launch, and Ingenuity is actively testing its capabilities right now. The 2027 launch of Dragonfly should provide enough time to engineer the technology developed from this research. Additionally, other rovers and landers, like India's Chandrayaan-3 rover, NASA's Viper rover, and Intuitive Machines Prime 1 Nova Sea lander, will be testing new technology or methods of surviving on planets. These procedures will help inform the development of new rovers and landers in the future, pushing the boundaries of our exploration capabilities. There are numerous semi-automated devices in Earth's orbit that could benefit from this type of automation. For instance, the James Webb Telescope may not be able to select its own targets. But what if it could use machine learning to suggest potential targets to its operators faster than NASA astronomers could? In the next few decades, we will not only be operating regularly around Mars, but we will also explore the asteroid belt, the outer solar system, and the Oort cloud beyond Pluto. We may even send far-ranging probes to other solar systems. The work being done with Ingenuity and Rashid is crucial to these efforts. By testing various types of automation closer to home, we can better prepare for these ambitious exploration missions. As we conclude our exploration of how NASA's Ingenuity drone got to Mars, we can't help but wonder, what's next for space exploration? How will future missions build upon the groundbreaking technology and engineering of Ingenuity? Will we see new drones and rovers exploring the outer reaches of our solar system? Only time will tell. But one thing is for sure. The innovations behind Ingenuity have opened up a whole new world of possibilities for space exploration. So keep your eyes on the skies and stay tuned for what's to come. Thanks for watching. Don't forget to like, subscribe, and hit the notification bell to stay up to date with our latest content. We appreciate your support and look forward to seeing you in the next video.